Hello, I'm going to be showing you some work that I've been doing on audio analysis with NuPIC. It's currently up on GitHub under Rhyolite at nupic.critic, and it basically will take a WAV file, any WAV file you pass to it, and convert it into NuPIC input format, which is what this convert WAV script does. There are several options on how to do it. You can change the sample rate and how many frequency bins you want. So it performs a fast Fourier transform on it, and you end up with a bunch of frequency bins. Then you run that input that step creates through NuPIC by passing in the directory it pushed it to using this run command. And there are other options. So I've got some default model parameters in here that I'm using that seem to be doing well for anomaly detection on individual fields. And then this is the step that takes the longest, is running NuPIC. That dumps all the output into another directory, and then there's another step that actually plots the results. So I'm going to be showing you a video, a plot of plotting, let's see, one of the audio files that I have been messing with. It's let me apologize ahead of time. I have bad taste in music, but this is from my library. It's a band called Sleep. Hopefully that you can still hear me talking over this, but it's just a long, chunky guitar. I picked it because it's very long and monotonous, and I want to identify where the song changes. So here's the song starting to play. Now, this top chart has got, this looks a little bit, I got a better idea. Let's make this larger, which I can do by passing the M option to maximize the window. There we go. So it's playing the song at the same time as it's showing you the plot. Oh. Well, that didn't maximize the window very well. Okay. I don't like this either. Let's do it without the maximized window. We'll have to deal. Alright, so here's the plot anyway. There's 10 bins, B0 through B9. They each represent a different frequency range. And the counts are just the counts of samples that were within those range. This is sampled at 5 Hertz and 10 frequency bins. That's every bin is plotted on the top chart. Seconds are along the bottom, so this is running live with the audio that you hear right now. And at the bottom chart you see anomaly likelihoods. Now the anomaly likelihoods are initially flat because it takes a while for that algorithm to get enough data before it starts producing anything. So it's just going to be flat here for a while while it's getting used to the patterns within this audio stream. So I can show you the input files. I've got this NuPIC critic project generates a lot of data. So let's see. This is sleep 5 Hertz, 5 bins, right? I forgot. 5 Hertz, 10 bins. There it is. So the input data looks like this. I've got one input data for each field, for each one of these frequency bins, and the run step of the NuPIC critic actually takes each one of these files, creates a model for each of them, and then dumps the output into another file in an output directory, which contains the seconds, the actual value of the bin, the anomaly score, the predicted value, and the anomaly likelihood. So that's what you're seeing here. You're seeing all the bin values, and the anomaly likelihoods are what's plotted on the bottom. So it looked like the anomaly likelihood just kicked in, and the parameters I used to the script, if I can find that, there we go. When I executed it was a anomaly threshold of 0.8 and a trigger of 5. So what that means is if 5 of these anomaly likelihood lines are above 0.8 on this graph at any time, it will mark it as anomaly. So watch this. I don't know if you were listening, but that was a big change in the structure of the song right there. Well, the main change was that the drums kicked in. So you can see it's noticed a difference in the FFT bins of the frequency distribution up top, and it started flagging some anomalous activity here. And you can obviously see it just by looking at the graph that the frequency distribution has changed. So that's what I wanted. Even before the drums really kicked in, there was that boom, 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 boom on the bass drum, and it caught that anomaly before the cymbals really started hitting. So at this point, it's settling down a little bit with this new pattern. The song's quite long, so I'll probably just let it play here for a while. My main goal was to make sure that I could get that first change triggered as an anomaly. There's other parts of the song later that it also triggers as anomalous. For example, I think there's a time change at some point that flags an anomaly, and then when the vocalist starts singing, that's also flagged as an anomaly. So, I mean, you can see the anomaly likelihoods are bouncing all over the place down here, so it's necessary to put some type of threshold, like I did, to help identify when a lot of the frequency bin anomaly likelihoods are high. And that's easy to change on the command line, you know. I could put this at 0.9 and say when any one goes above 0.9, that's an anomaly. You get a lot more anomaly indications for that. Or if you want to be really strict with it, you could put all 10 of them must be above 0.9, and you wouldn't get very many anomalies at all. So you could do this with any wave file, as long as it's mono. It doesn't work with stereo files, so that's something that could be added. But right now you need to have a mono wave file. One interesting thing that could be done with this is, let's see, there's this heart sound challenge, so I've been thinking about trying to apply it to this by training a model to recognize heart sounds, normal heart sounds, and then playing alternating heart sounds that are normal and ones with murmurs, and see how well it picks up the heart murmurs. So you see there was a bit of a change in the song here, and it caught an anomaly. And I think the song's going to slow down here sometime soon. This song is called Jerusalem Part 1 by a band called Sleep. It rocks. I think there's going to be a change coming up here. There we go. I was a little surprised it didn't catch that transition as anomalous, but it could be because it's heard this similar pattern at the beginning of the song. This is kind of the quieter part of the song, if you can believe that. And it sounds similar to what was at the beginning. But when we transition out of this, we should see some anomalies triggered. There we go. and then the vocalist comes in, and that should flag some more anomalies, or not. I thought the vocalist was, I've played with so many parameters on this, there's some that work better, and I haven't really tuned it and found out which ones are the best for which things. I've also done this for other songs. For example, I have some Steve Reich music. Let's see if I can find it. The Who, Reich, here it is. I think this is it. So this is the same. This only has 5 bins. It's a much calmer song as well. This only has 5 bins, and the sample rate is also 5 hertz, same as the last one. And the thing about this song is it has a fairly regular pattern, but different instruments are weaved in and out of this song over and over, as you can hear, like right now. So it's not as wonderful at picking up anomalies, like, because in this audio stream there's not really blatant anomalies, whereas in the other song you heard there was like a very obvious transition from one part of the song to the next, whereas this song there is not very many obvious transitions. There's just kind of blends from one sound into another, from one key into another, and rhythms kind of come and go and weave in and out of the composition. But they're looking through this, and this also takes a while to look through. Once the anomalies likelihoods engage here and we get a chance to see what they're doing, there are some anomalies that are picked up that do correspond with what you might call a transition or a change in the sound of the composition, which is really what I was trying to do. Like that was what I was interested in doing, was trying to flag when the sound of an audio stream changes somehow. How the change happens, that's harder to say, but like I would like to listen to something and say that something just changed right there, and hopefully NuPIC would be able to do that same thing, just with this limited amount of data from this FFT frequency distribution. There we go. So the anomaly likelihood is kicked in now, and we should hear some. When we get an anomaly, it usually corresponds to some subtle change or some introduction of a new instrument playing a new note over and over that it hasn't heard. But it's a lot harder to find anomalies in this. So you might have heard that there was a tonal change right there. Like there was a bit of a key change right there, and it picked up something. But it's much, much more subtle in this composition. So there was also a change there that threw an anomaly. It tends not to trigger in the middle of some sequence of like sonal patterns. It tends to trigger when there is some form of transition from one pattern to another, which is good. Sometimes it misses transitions, like you might call that, what we just heard, a bit of a transition. But there's so many of them, it's hard to tell what should and what should not be an anomaly. You can obviously tell just looking at these charts, there's cycles that the composer is going through, bringing in and out higher and lower frequencies. And we just had another anomaly on that transition. And like I mentioned, these are this red zone here is all tweakable by these options I passed in. So in this case, 3 of these anomaly likelihood scores have to be higher than 0.8, and that's what happened in this period. And these are totally tunable, so you might find that a different configuration works better for an audio stream that you're trying to analyze. It's a lot of range there. I've listened to this quite a while, and the further you get into it, the more sort of anomalies pop up, but the more things are changing too. Anyway, so that's that. You can see all of the options for these scripts, and you can run this on your own WAV files, I would say, pretty easily. So give it a shot if you're interested.